Hello. That's wait. Can you hear? I don't know if you can hear. Hello, Chris. Hello, Cheska. Hello. Wait, I saw the waves. Thank you. I don't know if you could. Hello, Paulina. Hello, Michelle. Wow, there's a lot. Wow, Michelle, Yavi, Maria. Good afternoon, Paulina, Allison, Michelle, Maria, Michelle. Wow. Why do I feel like it's more popular? Wow, there's like almost like there's like an eclipse or something. Saying Yavi, hello, Stephanie, hello. Wait, okay. Did I get Katie? Hello, Freddie, hello. Peace on earth towards physicists. Wait. Um, Stephanie, hello. Emily, good afternoon. I mean, Stephanie, good afternoon. I mean, Yavi, good afternoon. I mean, Katie, good afternoon. I mean, Freddie, good afternoon. I mean, Michelle and Marilyn, good afternoon. And Maria, afternoon. Michelle Q, good afternoon. Good afternoon. Paulina, good afternoon. All right. Wow. Feel like there's like, okay. Um, some announcements. Where's my board? One sec. Oh, for heaven's sake. All right. They want me to re-sign into the board. This may not be worth it. Okay. A quick announcement. The board may or may not come back. I don't have your exams yet. I I don't have your exams yet. You will have that. I don't know what to say. I You'll have them when you have them. I mean, earlier rather than later. But I'm not on top of that. Um, uh, you, I'm a little bit behind with things in general. So one thing is in terms of, and there's still many homeworks to come back to many of you. Um, but some are coming back. The Doppler effect homework, you may it we have to talk about the correct answers and the correct way of doing it and stuff, because that problem does, there's usually a Doppler effect problem on the final exam. It is something we need to know. If you did it at all and you handed it in, if you made any responsible effort on it and you handed it in by today, then you got full credit on it, which is terrific, and you deserve it for you being on top of things. And you haven't, and you're owed still a lot more points, and hopefully you'll get a lot of points on the exam. But congratulations, if you did it, you got full credit. That's awesome. It's part of me, my way of just saying like you're meeting me more than halfway in this course. But that doesn't. But as far as feedback, or as far as like making sure that you understand what you need to understand for it for the final, it is possible. Well, to cut to the chase, we need to know how to solve Doppler effect problems without just relying on that one equation from lab or that one equation that you find on the internet. Like, I'm not saying that equation's illegal. I'm certainly not saying it's wrong, but it doesn't tell the whole story, and it leaves out a lot of conceptual content that we need for the final. Most specifically, the thing with that one equation that you have in lab, I mean, I think many of you used in lab, the thing about that one equation is, yeah, it's a shortcut. If you really get it and you memorize all the different when to do positive in the numerator and when to do negative in the denominator, et cetera, you can get it right and stuff, but it totally skips the issue of the wavelength. Like, there's no way using that equation you can figure out what the wavelength is from either perspective in a Doppler effect problem. And to me, conceptually, part of the whole purpose of the Doppler effect is to see what's happening to the wavelength of a wave. So this is just a long way of saying it doesn't. However, you did the homework is fine, and you got full credit for the homework, especially if you, especially if it got you right answers. But I don't want you to misinterpret that to mean that then you're set and know the whole story, like for the final exam. You need to know how to do the Doppler effect by the method that we did last Wednesday. Like, so it's in the class notes from last Wednesday and it's on the YouTube video. And what I'm talking about is the 3-stage method where you start by solving for the wavelength. Like, again, and if there's more and I'm not done talking about it, but this is like, I just want to clear the air. You have to know how to do that. Even if you also know the other way. Okay, that's one thing. Wait, someone else is okay. Or is that, do you sort of know what I'm talking? Raise your hand if you like, if you know what I'm talking about, if you get my point. Like, okay, all right, cool. Thank you. Okay, that is not criticism. It's just because I know I'm funky with feedback sometimes. I just don't want to fool. I want everybody to get good grades, but I don't want them to get fooled into thinking, okay, you get my point. All right, so that's that. Now I'll be honest, sort of. What we were going to do today, and I had that. What we were going to do is finish going over that Doppler effect thing. Like we were going to go over the homework and see the 4 answers for the 4 different cases. And we were going to have a discussion about how the 4 cases compare the answers, because that's like really the purpose. It's not just an arbitrary problem. There's conceptual content to the comparison of the 4 cases. And I'll start by saying this for sure. Yes, if you did it right, whatever method you did, you would have gotten 4 different numbers for the 4 different cases in the homework. You would get 2 numbers that are greater than 800 hertz, but by slightly different amounts. And you'd get 2 numbers that are smaller than 800 hertz by slightly different amounts. Now, that is noteworthy. It's worth discussing why that is and what that means. And it all means something about relativity. However, before I go too far on all of that, that's what we were going to do today. And maybe we still do it, but probably we're going to end up doing that Wednesday. I'm not going to leave it hanging, but we're probably not going to do it today. Because it occurs to me, it's so ludicrous. Like I'm obsessed with relativity, right? I mean, relativity, the fact that velocity is a relation between 2 objects, not a property of one object. Like, I think that's the heart and soul of physics. I talk about it a lot in Physics 203. I'm trying to emphasize it again here. And another weird way of saying that, or the whole, is that it's the heart and soul of physics is the idea that you could be standing on an Earth, feeling stable, feeling stationary, while in some part of your brain somehow believing that the Earth is hurtling through space at 65,000 miles an hour past the sun, right? That's relativity right there. That's an example of relativity, but it's also the example that led to this whole idea of relativity and to physics. It's literally that idea of whether the Earth is moving through space or not, whether the Earth goes past the sun or the sun goes past the Earth. That whole fight or the resolution of that fight is what gives birth to what we know as classical mechanics, classical physics, Galileo, Newton, and then eventually Einstein. I mean, Einstein's not classical, but like that whole trajectory is all starting with, wait, is the Earth moving or not? How could we say that the Earth is moving if we don't feel it at all? But on the other hand, how can we explain certain things like the retrograde motion of planets and stuff like that, if we don't start entertaining the possibility that maybe the whole universe isn't going around the sun, right? Entertaining the idea that the whole universe is not going around us, right? The idea that we're not the center of the universe is really what starts what we now know today as physics, okay? And that's something that's like near and dear to my heart. In other words, what I'm really babbling about, you may have already picked up on this, what I'm really babbling about is astronomy is the mother of physics, like for real. Like physics, all that we know about motion on Earth comes from our struggles to figure out what's going on in the sky and the data that we've had from the sky for thousands and thousands of years. Like, you see where I'm going with this, I'm sure. Like, it's impossible to go to a certain depth or length or appreciation of physics without realizing at some point that it's all coming from astronomy, that all of the laws and all of the principles that we say about how things move on Earth are starting with the recognition that we're just a rock floating through space or flying through space the same way that all the other rocks and fireballs are flying through space. So I have spent some time in my life loving astronomy. It's ludicrous if you're all going outside in an hour and a half to see the eclipse, which I hope, or in 3 hours. Well, all right, let me pause right there. Obviously, where I'm going with this is, I was about to do a normal class today, but like my whole family is getting all like fired up and ready to go see the eclipse. And the whole world is getting all ready to see the eclipse. And like, it just hit me 5 minutes before class that it's sort of preposterous of all things to have a physics class with a physics teacher who cares a lot about astronomy, to not like have a pause and acknowledgement about this before we go on. So first of all, So we're going to suspend the Doppler effect for at least a couple of minutes, if not the whole period, because it's just too much of an opportunity. So first of all, could you raise your hand or electronically indicate, are you guys like going out to the jaywalk or doing something about this? You're in lab. Oh my God, wait, wait, oh my God, wait a minute, wait, I'm looking at the chat. Wait, oh my God, at least it's not, if it were my lab, I would, wait, is it you? Oh, you've quant. Wait. You like your eye. Okay, well, okay, fair. Oh, you like your eye. Rip guys. Okay, wait. So you're all in quant during the eclipse and they're not walking outside or any? You are going to, because some of you are going to, because I thought Dr. Ed was doing a whole thing on the jaywalk about, I think Dr. Ed is organizing some whole, Edgardo, he is. Okay. All right. I'm not telling you to leave another class. I'm not saying that. Okay. Okay. And I'm not telling you, I mean, and look, the hype is a little, okay. So, but let's just talk about you have a tutor. Yeah. I look, I've gone through a dilemma about this. So I want, you like your grades. Okay, fair enough. I'm going to tell you right now, though, because today is weird, because I don't have your exams back anyway. Well, free drink. Yeah, I mean, hey, look, so let's just talk about this for a minute. Because, I mean, again, if you have physics class on the day of the eclipse and you have a physics professor who happens to be, I've spent a lot of time with astronomy in my background or in my life. I mean, I used to teach it to little kids and like it just, whether you're going to it or not, the more I think about it, it would be a shame if we didn't acknowledge it at some level today, because it is true that a total eclipse of the sun. Well, and also, I also have to admit, as now you guys know, I guess like I don't even live in New York City. I live more on the path of it, or whatever you call that. Like, so everybody around where I live is going bananas, and my whole family's going bananas. I'm a little bit freaked out by the going bananas aspect, but I do get it. Wait, is MC your lab professor? Wait, who is your lab? Wait, do some of you have quant and some of you have physics lab? Or wait, no, it's Monday. Or you're talking about you have Justin today? Wait. I see what you're saying. It's not that you don't have him today, do you? Wait. Justin,
No, we don't have him today.
okay.
He's just doing it.
He's doing it. Okay. And you know, that's perfect that like you all know about his background, right? Like, right. Okay. So that's awesome. I should have known that. And I should have, I mean, I'm so out of touch. No, that's awesome. And look, so let's just be clear for a couple of minutes. Like you, or let me, I mean, forgive me, but because it's like it is a big deal and it's not at the same time, but it is. like first of all, you notice how every Mr. NASA man, exactly, right, the fact that he's got astronauts on his speed dial, right, he, wow, all right, good, all right, so that's good. No, you deserve that because it should be, especially if the whole world is going to make a whole freaking to do about it. Like, it'd be good if those of us who are actually, pursuing degrees in science and are educated and actually appreciate science, we should have some actual clue while everybody else is like freaking out with their science fiction understandings of it. But that's, and Justin's the man, right? He is the perfect guy to get okay, better than me in many ways. Certainly more exciting. Oh, nice. I just saw what Michelle Quach did. Did she do that the whole time or did she just change? I'm not sure. Okay. So look, notice, and on my board, you ever notice how every day on the board, there's like the sunrise time and the sunset time, right? On the right. And the phase of the moon, like every day for 2 semesters, like part of why I do that. And then I put the temperature, which is a funny paradox that I do that. Part of why I do that is because of the thrill of when it comes to astronomy. Astronomy is a shockingly precise science, right? Like part of the thrill of this whole eclipse thing, just to be clear, if it hasn't already dawned on you, is just the fact that they know it is true. It is that precise. Like just like we know exactly what time the sun is going to rise every single day. And to whatever extent we believe in the sunrise time, and I do, like if you believe that when I write the sunrise time for today, which I have here, but my board's not signing it, I'll do it in a second, if maybe. Like if you believe those sunrise times, you understand that like they're just as accurate to be predicted for 150 years in advance from now in Paris as they are for New York City tomorrow, right? Once you believe in that predictive model at all, it doesn't matter how far out you take it or where you take it. it's a pattern, it's a sine and cosine curve, actually, that is about as firm and reliable as anything in science gets. Like way more so than medical science, with all due respect. I mean, with all due respect to all of us, like astronomy is a far more precise science than medical science. Like that's why, you know, life is hard. So one reason everybody gets all excited about the eclipse is, yes, it's very, very infrequent, like every 20 years or so, that there would be a total eclipse of the sun that you'd be positioned correctly to see. But when it's going to happen, it's almost like no other prediction. You can just literally say it's literally going to happen, not probably, like definitely. But then the catch is, and so this is true. Like the sun, the sun is 93 million miles away from the Earth, right? 93 million miles, but we can predict something that's 93 million miles away. We can predict where it's going to be in relation to us. Out to like the seventh significant digit after the decimal point or whatever. That's 93 million miles away. And same thing with the moon, which is 250,000 miles away. Oh, their orbits, their patterns are so describable and predictable. And they all come down to cosine curves, I might add. And they were predictable. All of this business about eclipses and orbits and things like that. Bear in mind, all this stuff was almost as predictable. I mean, it not to the seventh significant digit, but we knew all of this stuff even the thousands of years before we were thinking of the Earth as going around the sun rather than the Earth at the center. Well, that's a whole other discussion, I guess. But one of the reasons people held on to so long for the idea that the Earth was sitting still at the center of everything is because predictions work perfectly well, even in that model, to a point, to a very, very extreme point, to a thousands and thousands of years of accuracy point. Okay, that's a sidebar. But the flip side of the eclipse, of course, as you know, is every day I put the rise and I put the set, and like the beauty of this, of science, of astronomy, is that those things are just known and you can look them up, and you can look them up years in advance and etc. But then I put the temperature, and the temperature is determined by factors within the Earth's atmosphere, factors that are like 500 miles above the surface of the Earth, not 93 million, not 250,000, like 500. And those factors, as you know, are wildly variable. Air currents, temperature gradients, pressure differentials within Earth's atmosphere, are wildly, wildly variable. So the weird thing about an eclipse is that, yeah, we know for sure it's going to happen. But if clouds cover this, if it just happens to rain or start raining 15 minutes before, that's the end of that discussion, right? Then that's it. So it's a little bit dicey. It's a little bit like the dichotomy of science, that things so far away can be so firmly known to us, but things so close, like the weather, are completely out of our grasp. And so, it is very possible to get everybody all hyped up and bring them out of class and bring them outside, and then two big clouds cover the sky and that's it, and you miss it. And of course I'm worried about that for my family. But wait, I'm looking in the chat. Hold on a second. I'm getting way off. I didn't want to oh, that's funny. Yes, I know. Turn around, bright eyes, right? I mean, yeah. Frankly, anytime anybody ever says even the word totally, I then think Eclipse of the Heart. Bonnie Tyler, right? Yeah, no, it was a great. My wife does that song karaoke frequently, more frequently than I care to admit, but I just admitted it. Okay. It's a good karaoke song. Okay. Did I just see this? See, there is an eclipse happening because I literally just talked about my wife doing karaoke in the middle of physics class. Okay. Um, 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 so, I do think, yes. I mean, if it's nice out, which it seems like it is, at least over here right now, if you're not in the middle of a class, it's true. It's a worthy experience, just in terms of knowing that everybody in a certain region of planet Earth is all experiencing the exact same thing at the exact same time. That's just sort of unusual and cool in itself. And knowing that you knew it in advance that it was going to happen, sort of cool in itself. Obviously it doesn't last very long, all of that stuff. And obviously it all comes down to a couple of points of light or not light in the sky. Like, but that's what all of astronomy is. Like all of us, just as my little quick plug here, like my one perspective that maybe other people aren't saying, I don't know. I'm not going to sit here and try. I can if you guys want, but I'm not going to do is sit and explain exactly what's going on with an eclipse. I think you're probably getting that. You've probably read that a million times in the New York Times or whatever. If you want to, I can, but I'm assuming that that's sort of boring at this point. I will say though, about astronomy in general, just think of this for a minute. Like on a given night, like not so much in New York City, but in a given night that isn't like filled with light pollution, on a given clear night, the naked eye can see somewhere between 1,000 and 2,000 points of light in the sky, right? Like stars and things and other things that look like stars, things that are planets or things that are mostly they're stars, but or even things that are galaxies. You can see approximately 1,500 points of light in the sky on a clear night if you're not in the middle of Manhattan, right? Okay, and just think about this for a second. Though that 1,500 points of light that you can see with the naked eye, I'm saying even before telescopes or even without any kind of instrumentation, with the naked eye, you could see like 1,500 points of light in the sky on a given clear suburban or rural sky. Now, here's the thing. Those 1,500 points of light, they're just points of light. They're just dots. Like to some people, they're totally uninteresting, and some people, they're very romantic. But all they are white dots on a black background, right? Those 1,500 white dots on a black background, that's a data set right there. That is literally a data set. And right, it's information. It is information in every sense of the word, where the dots are in relation to one another and where they are in 5 minutes or 5 hours or 5 days in relation to one another. Now, here's the thing. First of all, that data set has been the same data set since the dawn of human history, right? Just think for a second in terms of science, in terms of doing science, think about the fact that every night, if you want to, you can look at basically a scatter plot, like literally a scatter plot. You can look, or a data table, however you want to view it. You can look at the data that everybody else and anybody else throughout the whole planet has been looking at since the moment anybody's been looking at anything, right? It is the oldest data set available to anybody, and it's a data set that barely changes over barely, or certainly not in major. I mean, if it were a scatter plot, let me tell you that you got from Logger Pro or something, the ways in which it's changed in over thousands and thousands of years, like you wouldn't even notice on Logger Pro. You wouldn't care. Like if you were going to get an A thousands of years ago, you'd get an A today on the same, like it, but that data set is the data set that Plato was looking at, that Aristotle was looking at, that what, like, you know, that Pharaoh was what, like that Confucius was looking at. Seriously, one thing about the stars that's kind of wild is you're looking at the same data set that any other scientist or any other thinking person or just caring person has ever looked at in all of history. So you're in the same lab room with everybody else when you look at stars. That is kind of interesting to me. I mean, it's romantic, but it's also just like literally scientifically interesting that we've got a data table that we're all sharing. And here's the thing about that data table that might not be clear to all of you. You've heard of the constellations. All of you have heard of like I'm a Scorpio, she's a Sagittarius, whatever, right? You know, you've heard of the Big Dipper, whatever. Like no matter who you are, you've heard of these different shapes of the stars. Now you might think, oh, like the Dipper, that's so dumb. Like I can't believe they think it looks like a spoon. What are they on crack? Like it doesn't look like a spoon. But fine, you can say that the Dipper looks like whatever you, or you might think, oh, and they think the spoon is a god. Or they think the Scorpio is a god? Like, how silly is that? Fine, you could say all that stuff is silly. And you can say that thinking that you're a Scorpio, meaning that you were born under the sign of the Scorpion, like means that you should invest in the stock market tomorrow. Like, you could think all that stuff is silly, astrology, in other words. But let me make clear, it's when someone says that's the Scorpio up there or the Scorpion, right? Like, which is my sign. When they say, or they say Orion, that's Orion's belt. It doesn't matter whether you actually believe that it actually looks like a belt or not. the key thing is that you know what they're pointing to. When they go to those 3 stars and they're like, duh, see those 3 stars? That looks like a belt, right? You go, no, those 3 stars don't look like a belt, but you're both agreeing that those 3 stars are in a certain formation, right? And here's the thing that maybe you don't know or not everybody understands. Whenever you point to a piece of the sky and you go, that shape, those 3 stars like that, or that thing that looks to you like a spoon or whatever, that shape is always that shape. Just think about that for a second. When we say the Big Dipper, or we say Orion's belt, or we say, the twins of Gemini, whatever, what we're saying is that the stars are in a formation, that we all agree that they're in that formation, and they're always in that formation. Always, every night, if you can see them at all, and every year, right? They march across the sky. The reason that some of you are born like Scorpio and some of you are born Aquarius or whatever is because the star shapes, the constellations, yes, they move across the sky like every day or every night if you ever pay attention to them. Yes, all the stars, like the zodiac constellations, they rise in the east, just like the sun. And they go up in the sky and they go to the top and then they come back down to the west, just like the sun. They do it at night, the sun does it, right? They're all moving. And so some of them are like visible in winter and some of them are visible in summer, et cetera, et cetera. But the key thing that is important to know about stars in the sky is that they're all moving as one canopy, as one stretched curtain together. I'm getting into, this gets us into relativity is where I'm going with this. I'm saying that it's very important. Like some of you might think astrology, maybe you think interpretations are BS. Fine. But I'm talking about, and I'm not saying they are or they're not. I'm just saying if you want to dismiss astrology and horoscopes, that's not the province of this class. That's your decision to make either way. But astronomy, saying that there's a constellation called Scorpio or saying that there's a constellation called Pisces or whatever, that's not BS at all. That's literally just like saying on the map of the earth, there's a coastal line that defines the United States. And then there's a coastal line that defines Canada or, China or whatever. Like, of course, it's up to human beings to call them China or to call them United States or whatever. And of course, we have wars that change the borders and all that. But there's a coastal line, right? Like there is an actual shape to these land masses on the planet. We didn't make up the shapes, and the shapes are pretty stable over time. Same thing in the sky. The stars are in shapes, and the shapes, they're in formations called constellations. The constellations move across the sky every night from east to west across the southern sky, but they all move together. The reason that Orion is always Orion or the Dipper is always the Dipper is that all the stars are moving at the same rate relative to, they're all fixed. They're all going zero relative to one another, but they're all moving at some speed relative to us. So, and that's why Shakespeare and other people call it like the canopy of stars, because it's as though one big curtain stretches these stars past us every night as one. Now, so first of all, that's one big data set that is going past us every night and every day, like forever. And it's the same data set that whatever Archimedes looked at, etc. That's already kind of interesting, like 1,500 dots that are there going across all together all the time. But the real kicker, and this is where I'm going to stop, the real kicker, just so you know that people don't talk a lot about eclipses, is that of those 1,500 dots that are all moving together all the time, there are seven that with the naked eye can be seen to be moving differently. Not only differently from all the other 1,500, but differently from one another. Just think about that for a second. There's 1,500 dots. I'm saying 1,500, like average, like it's anywhere between, I'm talking about naked eye now. I'm talking about what anybody and everybody could see without fancy equipment and before any kind of industrial revolution or whatever. Like what everybody could see with their naked eye is about 1,500 dots that all move together as one every night, which would tend again to make us all think like, okay, we're here at a center. There's a sky, a heavens moving past us. They're all attached to each other, except there's seven that don't do what all the other 1,500 do, like literally exactly seven. Now, two of those seven, it's not surprising because they look so different from the other. Like two of them, of these 7 points of light that don't move at the same rate, that don't move at the same velocity across the sky as all the others, two of them are obvious, the sun and the moon. When I say obvious, I just mean like they're so blatantly different, like they're so much bigger than the others that it's not a surprise that somehow they're special. We don't know why for most of history, but there they are, the sun and the moon. Okay, so there's the sun and the moon. But then there's 5 others. There's 5 other dots that in every way look like all the others. If you just look on any random night, you wouldn't be able to separate out these 5 from the others by any special properties at all. The only way you would know that these 5 are special is if you stared at the sky long and hard and drew pictures night after night and night after night. You would notice that these 5 don't stick to the formations of all the others. Can anybody name what those 5 are? Oh, wait, I'm looking in the chat, but I'm about to sing. Yeah, we will have a karaoke class at some point. But were you with me? So I'm almost done babbling, sort of, but not really. But like I'm saying, well, there's 5 others, 5 other dots that look like all the other dots. Some of them are brighter than the other dots, but some of them are not. They look like all the other dots. They're just dots of light, but they don't stick with all the other dots. That's a really good guess. Okay, Katie just put, that's a really good guess. It's not actually right. Well, it's a really good guess. The deal with Polaris is that Polaris is she put Polaris in it. It's not Polaris, but that's a really good guess. Polaris, the pole star, the North Star, is the star that all of them are centering or are swirling around. It's the center of the whole motion every night. It's the one right above our North Pole. So once you start thinking that we're rotating, it makes sense. Like if you think which is a very recent idea, that we're spinning through the Earth, then the whole sky spins around us from our perspective. But whatever star is like right above the axis of our spin would be the axis of the sky spin, and that's what Polaris is. So Polaris just like sits there. So it's a really good guess. It is exceptional in a way, but I'm saying that there's 5 stars that move back and forth across the canopy, that they don't stick. Polaris is like the center of the spinning canopy, but there's 5 that cut across, like sometimes go ahead of the canopy and sometimes fall behind the canopy. Just raise your hand if you even understand the question I'm asking. Okay, that's a Chris, sort of. Oh, and that's a Maria. Okay. Well, so the other 5 are what we now know as, what we've always known as Mercury, Venus, Mars, Jupiter, and Saturn. Now, once you hear it, it's like, oh, but here's the thing. I just want to, and I'll stop yammering like this in a moment, but I just want to give you some perspective, like on astronomy and on the skies. You ever notice that? Oh, sorry. Oh, the number 7 is a big deal. Like, think about this? Every unit of time, like 365 days of the year, like 12 months of the year, all those numbers are all coming from cycles in the sky. You know that, like 365 is the number of times this happens for every one of these, right? And 12 is the number of times the moon goes around us for every one time we go around the sun or the sun goes past us. All those numbers, those divisions of time come from cycles in the sky. But 7 days in the week, where did that come from? Why is there 7 days in the week? What's so special about lucky 7? 7 is it's not a cycle, but it is astronomical. 7 is the number of what were called forever, for thousands and thousands of years. 7 was the number of the wanderers. The 7 wanderers are the 7 dots of light that for some mysterious reason don't move like all the other 1,500. Now, 2 of them are really big, the sun and the moon. So they're called the major wanderers. Like they're like, whoa, we know something's going on with them. But then there are these 5, the minor wanderers, Mercury, Venus, Mars, Jupiter, and Saturn. People have been studying them and obsessed with them for thousands of years, not about knowing only one thing about them, that somehow they don't move like all the other dots in the sky. They are the exceptions in the data set that makes the data set worth pondering for science, for people, for thousands of years, way before they had a telescope, and certainly even more deeply after they had a telescope. Like the seven wanderers are the issue in the sky that pushes forward the study of astronomy and then eventually the study of physics. Wanderer is the Greek word for planet. The seven original planets are Sun, Moon, Mercury, Venus, Mars, Jupiter, Saturn. The seven original planets are Sun, Moon, Mercury, Venus, Mars, Jupiter, Saturn. Not Earth. Earth is not a planet. Earth is sitting here. A planet is something that wanders mysteriously across the sky. Earth doesn't wander across, from the naked eye perspective, Earth doesn't wander across the sky. It sits underneath your feet, right? And Uranus, Neptune, and Pluto are not anything until you have a telescope. Then you notice them, and then they get into the club, and then they fall out of the club, and blah, blah, blah. But what a planet is originally, a planet is not a rock. A planet is not a thing that might have alien life on it, blah, blah. All a planet is a dot that moves differently from the other 2,000 dots and causes us all to go, what the heck is going on up there? How is it that 2,000 things are attached to each other every day, but 7 things are off grid, flying around, doing their own thing? What the heck are those 5? That's the issue for thousands of years that leads to Copernicus and all these different weird, wacky ideas, like maybe we're moving. Because it's so wacky, you could explain the motion of the 1500 really easily. But then you've got these 5 little dots that won't play. The 5 little dots plus the sun and the moon make the 7 wanderers. And if you don't believe me about the 7 days of the week, if you know French or Spanish or like any Romance language, think about it. Like Sunday, Monday, what's Tuesday? Tuesday's martes in Spanish. Martes. What's Wednesday? Miércoles. What's Thursday? Jueves with a J, right? Like think like it's literally, it is like sun, Moon, Mars, Mercury, Jupiter, Venus, like viernes, right? Sábado, Saturn. Like that's what the week is. Those 7 exceptions that prove some kind of cosmic rule that we don't get our hand around until Galileo finally says, you know what? Like all of this is so much easier to understand if we actually start saying that we're a rock also. We're a rock if we start saying that we're a moving rock, and we start believing maybe that some of those wanderers, like Venus, maybe it's not made of light like the rest of them. Maybe it's made of rock also. Galileo, one of the big reasons that he starts to realize or believe maybe that we really are moving is that he looks at Venus through a telescope and sees that Venus is undergoing phases like our moon does. Like sometimes is a crescent, sometimes it's half, no one ever had seen that before. In thousands of years, no one had ever looked closely enough at Venus to tell that actually it changed its shape. And everybody had known for thousands of years why the moon changes its shape. Why? Not because it really does, but because it gets covered in shadow, because it doesn't make its own light. Right? The moon, you all know this. Back to the eclipse. The moon doesn't make its own light. It bounces light off the sun. So if it's in the wrong position, it can't bounce all the light off the sun. It gets cast in shadow and we only see part of it. Turns out that happens to Venus. Who knew? Nobody knew because no one had a telescope. Venus does that. So Galileo's like, oh my God, wait a minute. This point of light might actually be like a rock, like the moon. So if that wandering point of light is actually a rock, could this rock below my feet also be wandering? Like that's not a proof, by the way. That's just like a big leap, but it's motivated by that recognition. All right, I'm babbling. Wait. Yeah. The whole Pluto thing is hilarious too. Let's move to Pluto. Yes. Okay. So we got 35 minutes. So here's what I'm going to do. Since some of you, I can tell by the jokes. Apparently some of you are hearing me. So I'm taking a big risk here. I know I'm like totally off page, but I feel like, yes, eclipses are worth appreciating. Astronomy is worth appreciating since they come along so infrequently. if you can go out and see it, see it. But if you can't, at least maybe you'll remember this day. If other people are like, did you catch it? It was the best day of my whole life, which will not happen. But if people like shame you and then you're like, yeah, I was sitting in quant class, then at least maybe I'll give you something else that's weird and cheesy. I'm going to take a risk. I'm still off topic here. So bear with me. I did something with your predecessors, the class that took 203 a couple of semesters ago. By accident, one day I decided to do the following, and they seem to appreciate it, or they're lying maybe, but so what I'm going to do now, bear with me, forgive me in advance. Like, you don't have to take notes. You don't have to take notes. It has nothing to do with exams or grades or wait, I was a skater boy. Okay. Maybe. Sort of. Talk about being vulnerable. Here's what I'm going to change the view of the screen. Hold on. I'm going to read something to you, okay? At least it'll be relaxing, if nothing else, okay? It's not on any test, but this is a children's story I wrote a long time ago, and you can get it on Amazon, whatever. It's a children's story that is meant to try to get across. It's meant to be an allegory, sort of, to get across how it is that based on looking up in the sky, we even ever came to entertain the relativistic idea that maybe we were actually moving, even though no evidence on Earth seems to suggest that. Okay, so I'm going to, again, I apologize in advance. I'm going to read you the story. It seems to have it's more of a 203 kind of story than a 204 story, but I think it's relevant for the day of the eclipse. So at least you'll have some kind of astronomy experience today. When I'm done reading it, I'll probably literally just shut down because it's like too embarrassing for me to hang around afterwards. Hopefully I'll finish it in time before the class is over. I think I will. But when it's over, I'm just going to shut down and I'll see you Wednesday and we'll go back to the Doppler effect and all that. But hopefully this will give some perspective on the sky, whatever. So, and if you leave, I won't know the difference. But it seemed to help people in Physics 203 a couple of semesters ago. Okay, so the story is called "And Still It." Oh, love that. Wait, what? Love that. Wait, Well, I mean, it took me a long time. Yeah, it's story time. It's story time. I wrote this I started writing this when my older son was like, used to crawl around in my office at another school I worked. When my older son he wasn't older then. He was like an infant and he would crawl around in my office and in my lab at another school I worked at. And by the time I actually finished it and put it on Amazon and everything, I had a second son. So the characters are whatever, but it's meant to be like how it was my attempt to try to get across this guy. Well, whatever, you'll understand. So it's a children's story. Okay. So, but hopefully you'll enjoy it and hopefully it gets something across about the sky. So it's called "And Still It Moves." It's 7 chapters, not coincidentally, but they're short. They're very short. Chapter 1, Sun. Jesse, Missy, Jean, and Professor P.O.P.O. lived on a land called Earth. Earth was a big land, divided into many small places. Their place was called 40 degrees north of the equator, 74 degrees west of the prime meridian. Their time was called the first day of autumn. Once again, it was late at night. It was thrillingly late. So late that somehow a little bit later and soon it would be early. In the morning again, way before the afternoon. It was never fully clear how that part ever fully worked. But once again, Jesse, Missy Jean, and Professor P.O.P.O. were in the laboratory on 4, near the corner of 10 and 59, in the building named T of John J. Once again, Missy Jean was at the counter working on a secret potion. This time, thus far, the potion involved sodium bicarbonate, yogurt, ice chips, and a few iron filings. The potion did not do what it was supposed to do, but it was, however, unusually magnetic for something so tasty. Jesse was on the floor studying how rattles and small stuffed animals behaved when he did not put them in his mouth. Jesse had very recently started to make observations under this challenging condition. His observations were still limited. He was fairly convinced that stuffed animals, when kept away from his mouth, were neither tasty nor magnetic. Professor P.O.P.O. was at his desk. Without looking, Missy Jean just knew it, and she knew what he was doing, scribbling symbol after symbol, all somehow neat and yet somehow unreadable at the same time, in that thick brown journal of unlined paper. He called the symbols math, but Missy Jean knew better. Missy Jean had learned math last year at her school. Her school was called 92 Street Y. Her class had finished all of math in time for summer, and she even got her big sticker sheets correct. So Missy Jean knew what math was all about. It was all about numbers. Whatever symbols covered Professor Pio-Pio's unlined sheets, they were certainly not numbers. Professor Pio-Pio looked at his watch. He looked at Jessie and he looked at Missy Jean. He said, "Let's go outside and see something beautiful." Nobody wished to argue this plan. Missy Jean put on her shoes. Professor Pio-Pio scooped Jessie off the floor. They went outside, hailed a cab, and stood on the edge of the drive called FDR. The three looked off to what Professor Pio-Pio called the east. A sphere of blazing crimson was rising magnificently behind three buildings near two bridges that came off one short place. The place melted off into a mysterious island that Professor Pio-Pio called Long. Right now, it was too long to see and too wide to cross, but it all grew out and left, if Jessie heard Professor Pio-Pio right, from a blue part called the Sound. Jessie was a little confused by this name. All the ups and overs and outs and colors seemed so nice, so slow and silent, cool and quiet, not like a sound, but also not like a picture. Not at all like one of those pictures you could hold in your hand on a buzzing phone. No, watching the sunrise was more like sitting on the couch with Missy Jean in a peaceful movie, but lost in cushions made of clouds and no reasons to rewind. Things were calm and clear with Missy Jean. She even knew how to spell movie, DVD, and how to take care of him. He was proud of her for that. At that moment, at least, things were not unclear to Missy Jean, but neither were they clear. They just were. She had stopped listening to Professor Pio-Pio or to anything else from the moment she started looking. Her mouth hung slightly opened. She did not hear Professor Pio-Pio when he told Jessie that the fiery circle was called the sun. She did not at that moment need to know whether the treat was called a sunrise or a run size or a Googleplex. It was a treat no matter what anybody wanted to call it. The three remained quiet for a long time after the stars faded from view and the sun dominated the low sky. The whole thing was indeed a movie. Both the fading stars and the rising sun trekked from one sky edge on their way to the other. It appeared as though Missy Jean, Professor Pio-Pio, and Jessie were under a big round tent. Somebody invisible was pulling the tent top from left to right. At last, it dawned on Missy Jean. It might be nice to see that again sometime. She paused. But some other time, I think. I'm too happy right now. Jessie was also happy. He was happy for the sun. He was sure the sun would get some rest and burble up again some other time. Jessie, Missy Jean, and Professor Pio-Pio went home and ate and played and napped and played and ate. Okay. Chapter 2, Moon. Before pajama time, Jessie was aware of the dusky traces of sunlight. Were they coming or were they going? At the lab, Jessie found Missy Jean. She too was looking forward to another sunrise. Finally, Professor Pio-Pio said, "Let's bring our suppers outside and see if the sun rises again." And so they did, but so it didn't. Instead, they saw the moon, far higher than the place in which they had recently found the sun. The moon was bright and beautiful, but it looked like someone had bitten it. Half of it was missing. Why? Thought Jessie. He remembered one night when the moon looked like a perfect circle. He remembered it well because the moon kept following around that night, even when he was in his car seat, zooming up that same FDR drive. What kind of creature would eat his moon? Jessie thought, and Missy Jean asked. Professor Pio-Pio assured them, "Don't you worry. The moon's still there. Part of it is just hidden in shadow. The moon cannot make its own light the way the sun can. Sunlight bounces off the moon and heads towards our eyes. Sometimes more gets bounced, sometimes less. It depends where the moon is." Supper was long, leisurely, and quiet. Missy Jean was deep in her mashed potatoes. Jessie was deep in thought. How do some things make their own light? The sun did, but the moon didn't? Did he? Did Missy Jean? Professor Pio-Pio probably made his own light. He certainly made a lot of his own noise. Chapter 3, Stars. Well, what about the stars? Asked Missy Jean. Why can't we go say hello to them before we say goodnight to ourselves? Why not indeed, replied Professor Pio-Pio. The three walked outside and Professor Pio-Pio pointed up. You see that sideways V that looks like a mouth? It's the head of a bull named Taurus. That bright red giant star, Aldebaran, is the eye of the bull. Missy Jean and Jessie loved animals. They kept their eyes on that bull for a long, long time. Long enough, it turned out, to notice that it, like all the animals and the fish and the twins and the hunters and everything else around it, it seemed, slid smoothly across the sky, from down and left to up and center to down and right, it seemed. Good job, world, said Missy Jean. You just keep turning around us like that. Yes, good job, world, thought Jessie. Good night, you two, declared Professor Pio. The early bird catches the worm. Missy Jean was not so interested in catching a worm, but Jessie had no strong feelings on the matter. His eyelids dropped fully by the word bird. Somehow later, he found himself in bed. Chapter 4, Venus. The next evening, the three rushed outside and zoomed over to the Hudson River to see if they could catch the sun setting in what Professor Pio called the west. There was a big tugboat blocking their view. Sadly, it seemed that they had arrived too late. Happily, however, they arrived just in time to see the biggest, brightest star they had ever noticed. It seemed to be setting, just like they had been hoping for the sun. But this one was not the sun. Wow, dazzling, thought Jessie. Is that super duper bright star always to the right of Taurus? Asked Missy Jean. Well, actually, no, explained Professor Pio. That thing wanders back and forth. It wanders back and forth across Taurus and the other star formations, but it always stays near the sun. It wanders past the bull, the ram, the scorpion, and the other 9 animals who march together across the southern sky. Because it wanders, it's actually called a planet. It's the planet Venus, finished Professor Pio. Jessie suddenly felt different from how he had felt a moment ago. He had been excited happy. Now he was calm happy. It was funny how having a name for something memorable seemed to solve a mystery. It was also funny how a mystery's solution could create its own confusion. Which was more fun, searching or finding? Chapter 5, Jupiter. The next night involved more searching and more finding. The three went out far later than they had on previous nights. After this evening's dinner, juicy chicken to eat and chickeny juice to drink, they played and sang and danced and sang and danced and played for tons of time before heading out to the edge of the valley. The sun was long gone. Venus was long gone. Even Taurus was getting close to that mountain in the west. But up in the sky, amongst the connect-the-dot crab that Professor Pio had called Cancer, blazed another unusually bright star, almost as big and beautiful as Venus. Neither Missy Jean nor Jessie failed to notice. How could they? Professor Pio did not fail to answer their unasked question. You got it, guys. That's another planet. Not all of them are that bright, but that one is. That one is Jupiter. Oh, planets aren't always that bright, but they do always dance to their own tune. Someday, some year, you won't find Jupiter among the crab stars. You'll find it among the lines of the lion or the specks of the sea goat. Chapter 6, Phases of Venus, Binoculars Recommended. The next and final evening, Jessie, Missy Jean, and Professor Pio rushed out early in order to try and catch the sun before it dropped behind the big mountain. Again, they missed it. It was too bad, but not too bad. Neither Jessie nor Missy Jean truly wanted to win in a competition against Mother Nature or Father Time. Any disappointment they might have felt disappeared the moment Professor Pio pulled two small but clunky black objects from his bag. Each object was a pair of binoculars. Jessie and Missy Jean each gazed toward the mountain through the long, thick glasses. Suddenly, it seemed as though they had stepped a dozen times closer to outer space. Without the binoculars, they spotted and recognized Venus. With the binoculars, a bit of confusion set in. Missy Jean spoke. Wait, now Venus looks like the moon. Jessie knew what she meant. Now that he was closer to Venus, it no longer looked like a wandering star. Like the moon, this circle was missing a chunk. So some sky wanderers did not make their own light? Professor Pio nodded as though he had heard Jessie's thought. Instead of answering, he asked a different question. Missy Jean, do you think the firm ground below you makes its own light? Missy Jean replied with confidence, No, silly, dirt isn't fire. Makes sense to me, stated Professor Pio. So last I'm just looking. Okay. Last chapter, moons of Jupiter. A second and final call for binoculars. Indeed, at some times, some space things were starting to seem clearer to Jesse. Yet he was surprised to find, at some other times, that the more he looked at some other things, the less clear the other things seemed to seem. If some sky wanderers did not make their own light, and if Earth did not make its own light, did that mean that Earth was a sky wanderer? It certainly did not feel that way. If circles were shapes, for example, did that mean that shapes were circles? It certainly did not seem that way. Yet something about those wanderers made Jesse feel a little bit dizzier in his mind and even dizzier on his feet. To make matters more surprising, Professor Pio then pulled 4 objects out of his pack. 3 large and 1 small, but all squishy. Jesse loved that pack. He loved how it seemed to be bigger on the inside than it was on the outside. Professor Pio unrolled the 3 large objects. They were sleeping bags. But neither Missy Jean nor Jesse noticed until later. They noticed the small squishy bag. It had marshmallows. Professor Pio explained, look, let's make a fire, roast marshmallows, and sleep under the stars. I'll wake you when Jupiter comes out. They did, and he did. Jesse and Missy Jean found Jupiter. Jupiter wasn't quite as sharp as Venus, but Jupiter was bold. Jupiter wore an orange robe. Jupiter was king. It sat solemnly on a floating throne in their minds. They did, and he did. Professor Pio offered last night's binoculars, those long black eyes that had shown them Venus's missing piece. Jesse twitched. Sure, he liked finding new things that were there, especially when they were hard to see. But last night's hollow bite from Venus was still eating at him. How had Professor Pio pointed out something that wasn't there? Something that before had seemed so easy to see? They clutched on and took giant steps toward Jupiter through their new and superpower eyes. When they stared at Jupiter, it was more, and so seemed closer. But when they stared at its black surrounding realm, that too was more and yet seemed farther. Their balance grew weaker, their vision grew stronger. Soon, in a line surrounding Jupiter, 4 brand new stars fuzzed into view. Whoa, exclaimed Missy Jean, delighting in her discovery. Oy, thought Jesse. Are those regular stars or sky wanderers? Asked Missy Jean, sorting out her discovery. Professor Pio replied, oh, those 4 that you can see now. Well, yes, those 4 wander all right. But they don't just wander around. They wander around together around Jupiter. Those are 4 of Jupiter's moons, which you can't see without a telescope or binoculars. A world of worlds going around a world. This is also Galileo's discovery. A world of worlds going around a world inside the biggest world of all? Jesse's thoughts swirled. They whirled. Jesse thought he had a funny feeling, but he did not feel that he had a funny thought. So, a thing in the sky can go around a thing in the sky that goes around a... cried Missy Jean. She slapped a hand on her own mouth to keep at least her last sentence from running away toward forever. So much was slipping, super slick, yet somehow steadily. Wait, and so a heavy rock can fly like light and wander through the dark of space? Wondered Jesse. The earth feels so still, and, started Missy Jean, and still it moves, saw Jesse. And as Jesse thought this thought, he too moved, but this time through time, toward the future. He grew older, perhaps you might say by only a minute or two, and only at the speed of life. Yes, but this time he felt it. That's the end. I will see you guys on Wednesday. Thank you for indulging me. See the Eclipse.